Hi everyone, my name is Vijay. I'm your TA for this course. I have my background in electrical engineering and I have also done my master's in cognitive psychology. And I took a 2020 version of computational neuroscience from Neuromatch Academy. So today we are going to learn about the forward propagation. So for basically the we're going to learn about the autograph or PyTorch autograph. So AutoGrad is basically a simply automatic differentiation system that is used in PyTorch and basically in machine learning system. So it computes gradients or the derivatives of the tensors by building a computational graph of all the operations that is involved by building a computational graph during the forward pass. And the AutoGrad also traverses through the same computational graph in reverse by applying the chain rule of derivatives and calculates the gradients for all the learnable parameters. So here in this tutorial, you can see basically a computational graph where x is our input function and w and b are our learnable parameters, which are forwarded through the hyperbolic tan functions. So basically, when doing a forward pass, and that is contrasted against a true ground value for computing a loss. We now move forward to the coding section. In the coding section, we have defined a class called simple graph in Python, whereby we have defined a method with parameters w and b. W and b are our learnable parameters, which are widths and biases. W standing for widths and b for biases. And as you move forward, you can see that this code basically means that W, our parameter, basically is an instance of float, or it takes floating values, and B also takes a floating values, and both W and B are initialized as a tensor, as you can see there, and it requires in this one we requires grad equals to true. It basically means that W and B are differentiable parameters or um, are computed as gradients, or basically we say they are the learnable parameters for the system. We then move forward to the forward function where our input parameter is x. So x is basically our input function, which is also a tensor. So our w and b both are also a tensor. Our input function x is also a tensor. And in this one, x is basically a tensor. And in this one, we have to do the prediction in the forward pass. Basically, means that our input function x and our learnable parameters are uh, forwarded through the hyperbolic tan function in order to compute the prediction. And then we define another function called square loss function where our function parameters are y true and y prediction. Y true and y prediction are both 1D tensors. Y true is our ground value and y prediction is our predicted value from the forward pass. Both of these are like instance of Dodge tensor. And then we have to compute the loss, and then this return loss will basically return the loss. So from these two parameters, we compute the loss. Since it is the L2 loss, we compute the loss by y2 minus y prediction. And since I told you it's a L2 loss, it will be 2, meaning squared error loss. So one thing I forgot in this one, and I'm really sorry, we need to do the prediction for the forward pass too. So like I said, it has to move to the hyperbolic tan function. So it's basically torch dot tan h, and it's our input function times self dot weight loss self dot our bias parameters.